All right, guys, so now we're on section 4.4, and the title of this section, this entire section, is trigonometric functions of any angle. So we began this unit with the unit circle, right, where we had a radius of 1. And I'm not going to spend too much time on this because you guys can read this, but just to get the idea, a basic notion of what's going on here, we began with a radius of 1 with our unit circle. But we can take the idea of that unit circle and extend it, which is what they are doing here. They're saying that we can extend our radius beyond 1. And the same notion, the same idea of those triangles that we formed on that unit circle, you can form triangles for any circle around the origin, so that's the idea of today's lesson. So you can go through. I want you to understand that our ratios have not changed. Before, when I said sine theta was equal to y, it was equal to y because our radius was 1. But our ratio, if you remember, let's write this down. I can do this really quickly, I think. What is it? Slipping on hard concrete always hurts the old. So sine is opposite, so let me draw this out. Sine is opposite over hypotenuse. So if I had a circle, let's just sketch this out. If I had a circle that was not a unit circle and I had an angle up here, and that was my given angle there, we could imagine that sine would be my opposite, which is this side, and my hypotenuse, which is the radius. Well, the radius now is no longer 1, right? The radius is whatever the radius is for this particular circle, hence the r in the denominator. And the y value correlates with the opposite side, and the reason for that being, oops, I don't want that. I want this pen. Because this height here, the opposite side, is going to correlate to the distance over there on that y-axis, right? So that is why we say that sine theta now is y over r, but it is still the exact same thing as opposite over hypotenuse. Do not get that confused. So you guys can go through that, look over these identities to remind yourself. And this chart right here is reminding us where sine, cosine, and tangent is positive and negative in the coordinate plane. I thought we had it. There's a little chart, I thought it was on here, to help us remember. There's a saying that says, all students take calculus. And what that means is, where are my markers? Okay, so what that means, if I were to add this in here, that all means that all, as in sine, cosine, and tangent, have positive ratios in that quadrant. Where students is, it begins with an S, that lets me know that sine is going to be positive there. Where it says take, that is where tan is going to be positive. And then where it says calculus, that is where cosine is going to be positive. But you guys can write that down, and that would be good to have for your notes. But let's take this a bit further. I don't want to take too much time on notes. You guys can read that. But let's look at example 1. It says, let the point P be at 20, negative 21. And let it be a point on the terminal side of angle theta, drawn in standard position. So let me zoom in just a bit and let me pause there and let me do what it asked me to do there. So I'm going to, or let me draw what it described. So I have a coordinate plane, and I have an angle where the terminal side ends at positive 20, negative 21. So that point is down here somewhere, okay? So I'm just going to put that. My point is down there somewhere. So the angle actually went around that way, right? But what I know is that point could be right there. Let me draw this up. So the distance here is 20, and the distance down is negative 21. So I can sketch that out, right? So it says find the value of sine theta. So I want to find sine theta and cosine theta. Well, what do we know sine theta to be equal to? We said that sine is equal to y over r. Okay, so let's look at what we have. I have let's change my colors. So my x coordinate would be 20. My y coordinate would be, length would be negative 21. What I do not have is the length of the radius. So, but I can find that, right, by using the Pythagorean theorem. So I can come down here at the bottom and say that x squared plus y squared must be equal to the radius squared, because remember our Pythagorean theorem again is a squared plus b squared equals c squared. I'm using the same idea, just changing the variables a little bit. And if we simplify that, I get, or what I know, I could just come over here to the side. I have the answer. I know that r is actually going to be equal to the square root of 20 squared plus a negative 21 squared. And if you stick that in your calculator, we should get exactly 29. So I'm going to put here that r is equal to 29. So what that means then is that my sine ratio is going to be negative 21 over my radius, which is 29. And then my cosine theta, we understand to be x over y. So now I have my x is 20, and my y is negative 21. And so I can just leave it, or I could just put a negative 20 over 21.